Hi everyone. Brilliant to see you. So today we're going to be doing a few of the basic ideas about volume, right? What it is, how we might measure it, and how we might find the volume of a cube or cuboid. So let's get started. So first of all, what is volume? You could think of volume, really, as being like the number of cubes that would fit inside a 3D shape, right? And sometimes we might actually be able to see those cubes, or at least the ones on the outside of a 3D shape. If we could see the cubes, we could actually count them, couldn't we, to find the volume of a shape? For example, here we've got a shape made of some cubes all stacked up. I can see that there's one cube here on the bottom, and then another one further up. 3, 4, 5, 6, 7, 8, 9, 10. There are 10 cubes there. It's a visual representation of 10 cubes. I can't see them fully because some of the bits haven't been drawn because they're hiding behind the front part of the cube. Yeah. And if it's difficult to interpret these to start with, it could be a nice idea to get some cubes yourself and have a go with maybe making a tower like this and noticing how some of the cube is kind of hidden at the back, right? When you look at a cube, when you count these cubes. So I could say that the volume of this big tall cuboid is 10 cubes. Like underneath that, so this front slice of this big cube has 9 little cubes in it. Can you see what I mean? And again, it can sometimes be a little tricky to interpret these to start with. It's kind of hard, isn't it, when you're trying to draw something that's three-dimensional, 3D, on a 2D piece of paper or a 2D screen. You have to use little tricks to help you. But hopefully you can see, or you've got a bit of an idea of what I'm meaning when I'm talking about these little cubes. So this is like a slice of the big cube, and then we've got another slice behind it, right? And this slice, we've got a cube here, a cube here. These are two faces of the same cube, and this is one face of another 2 cubes. A lot of this slice is we can't see, it's hidden by this front slice. But this slice would also have 9 cubes in it if you were to take it apart. And then we've got one more slice at the back that would also have 9 cubes in it. So altogether, this big cube is made up of 3 lots of 9 cubes, so 27 cubes. Quite difficult to count, really. There are other methods you could use, methods of multiplication to help you. Cubes. If we want to measure the volume, so how many little cubes would fit inside a cuboid or a cube, we can use this formula instead. If we know the distance across our cuboid, back to front and up and down, so these are the 3 different dimensions we talk about when we say something's 3D. If we know the lengths of all of them in the same units, we can just times them together, and that will give us the volume. In the previous question, I noticed that there were 3 cubes measuring. There was a height of my cube of 3, a width and a length of 3 as well. So if I'd realised that, I could have done 3 times 3 times 3 and got 27 in a totally different way. And maybe for that question, it would have been a bit easier. And we can do that for this one as well. So let's multiply those numbers together and we'll have a think about what it means as well. So 1 times 6 times 2 Make sure we do this carefully, 'cause it's easy when you're timesing three numbers together to get a bit confused and end up with a wrong answer. So 1 times 6 is 6, and then we times that by 2, and we get 12. Because these are all in centimetres, that's going to be 12 centimetres cubed, which is brilliant. It means that we've actually got a volume in some kind of meaningful unit, not these cubes that we don't know what size they are. And if I were to try and show you what that would look like if we did have some cubes, I'm going to try my best. Okay, so this is 1 centimetre going backwards, so that would just be 1 cube width, wouldn't it? We have 2 centimetres going upwards, so I'm going to break that into 2 cubes. And we have 6 centimetres going across. Ooh, okay, so I'm going to cut this into 2. That's 2 lots of 3 would make 6. So let me break this 6 down into 3. Oops, a little bit of sketching. This is definitely not my forte, but nice if you can have a little bit of an idea. So hopefully you can see that if this were made up of little cubes, you can see where the 12 would come from. It's because we're 1 cube deep, we have 6 cubes going across and 2 cubes going up. So there are 12 cubes that you can sort of see at least a little bit of each of them. This is 1 cube, this would be another one, this would be another one, and so on. Yeah? So that's where these 12 centimetres cubed come from. So it's literally the same thing. It's just 2 different ways of doing the same thing. We're finding out how many 1 centimetre by 1 centimetre by 1 centimetre little cubes would fit inside this big cuboid. Yeah? Make sense? What about this cube? I've only put 1 side length on this cube. That's interesting. Why can I get away with doing that? Well, the cool thing about a cube is because all the faces are squares, all of these edges are all the same length. So we've got this one, which is 2. So all the up and down lengths are 2. We've got this one, and that's going to be 2 as well. I'm going to change this colour, apologies. So this one would be 2 as well, which is the same, going the same direction as these ones. Oh, this is even worse. This purple. And then these ones are going to be 2 as well, right? They're all going in a slightly different direction. And even though they're all the same length, we can still think of one of these directions as the length, one as the width, and one as the height. And we're going to times them all together, okay? So we're going to do 2 times 2 times 2. Again, think about this really slowly and carefully. 2 times 2, that's 4. And then we times that by 2 to get 8. So our answer is 8 centimetres cubed. And you know what? If you have a copy of this, the copies are available on my website, you could even have a go at breaking this up and see if you can see where the cubes would be if you break each of these edges up into 2 1 centimetre lengths, right? I think you'd be able to see where the 8 cubes would be. There'd be one hidden right at the very back. Fantastic. One other thing to say, for cubes today, I'm going to be thinking about length times width times height. But because these are all the same, sometimes when you're thinking about the volume of a cube, you might see it written as something like length cubed or width cubed, I saw recently. So one of these lengths, one of these side lengths, times by itself and times by itself again, right? That makes sense. Oh, fantastic. I'm seeing some great comments actually about yeah, so some of you already having a go at making it with cubes, and you can see that it has 8. Fantastic, nice one. Apologies, I didn't notice the comment. Fantastic comment there initially. Well done. Brilliant. So, what about these? Can we find the volume of these cuboids? So, they're cuboids. So, to find the volume, we can multiply the length times the width times the height, right? The length, width, and height are just the three separate dimensions, the three different lengths in most cuboids. In most cuboids, they'll all be different, but in some cuboids, some of them might be the same, and in a cube, they're all going to be the same. So all I need to do to find the volume of this cuboid is multiply these three different lengths together. 2 times 3 times 10. It doesn't really matter which one you call the length, the width, and the height. And so I'm going to times this 8 that I didn't do yet by this 8. The 8 that comes from the 2 times 4. What does that give me? 8 times 8, that's going to be 64. 64 centimeters cubed. In other words, in this cuboid, there'd be 64 tiny little cubes if we were to make it. So if you have lots of cubes, I know some of you saying in the comments about making these shapes. If you had 64 cubes, you could have a go at making that and see if you can get it to look the same, but it would be to scale if you had cubes that were 1 centimeter by 1 centimeter. Whereas I think all of these images in my slides today are not to scale. So they might not look quite the same as the version that you make if you have a go at making them with cubes. Fantastic. It'd be great to compare. We're going to do length times width times height. Sometimes people call the longest side the length and the other front back or left right the width. And then the up and down one is usually called the height. But like I said, it doesn't really matter as long as we times all of these different lengths together, all of these different dimensions. 6 times 2, that gives us 12. Then we times that by 1. That stays as 12, doesn't it? 12 centimeters cubed. And finally, another cube. This time I've put all of the dimensions in. Not every single edge length, but I have put the left to right one, the front to back one, and the up and down one. These are the three different dimensions that we need to think about. But because it's a cube, because I can see that it's a cube, I know that they're actually all going to be the same. So we only really need to know one of them, don't we, if we know it's a cube? So I can do length times width times height, which is just the same as 3 cubed. The length, one of the lengths, cubed. When you cube a number, it means you times it by itself and then by itself again. So I would be doing 3 times 3. That gives me 9. And then I need to times that by 3 one more time. 9 times 3. Do you know what that is? I sometimes use the finger trick for the 9 times table. If you put down your third finger, because it's 9 times 3, you'll see you have 2 fingers on one side of it to make 20. That counts as 20. And you have 7 on the other side. So 27 is the answer. So just like that earlier question, 27 centimeters cubed in this case. The earlier one was 27 cubes. But I could calculate that much more easily than if I'd had to try and count cubes and some of them were hidden at the back, right? So unless you've got, like I know some of you have, some nice cubes to be able to model these, and it would be amazing actually to see what you're creating with your cubes, whether you're able to model some of these so that you can count the cubes. But unless you have that, which you won't always have access to, using this multiplication method can be a lot quicker once you practice your times tables a bit. That's another good reason to practice multiplying, because it's an important skill. Amazing. What about other units of volume? Well, I'm going to say again, these images are not to scale. This cuboid here has the length, width, and height all in millimeters. Millimeters are super, super, super tiny. I don't know if some of you might have a ruler somewhere nearby, but if you see a little centimeter on your ruler, sometimes a centimeter might be about the length of a square in an exercise book. That centimeter is separated into 10 tiny millimeters. So a millimeter really, really is tiny. A cuboid that was 5 millimeters by 2 millimeters by 15 millimeters would be a lot smaller than this one looks. It would look super tiny. But it's okay. Sometimes people draw things bigger than they are, so they're easier to see. You'll see how tiny they are. They'd be difficult to see. They'd be starting to look kind of like, almost like grains of salt, really. They'd be really tiny. So it would be 150 of those. And another possibility could be that we measure volume in meters cubed. So here we've got a cube with the side lengths in meters. And again, not to scale, because a meter is 100 centimeters. So a meter is going to be most definitely bigger than the screen that you're watching me from. If you find a ruler, maybe you could have a think about how many times bigger than that ruler a meter would be. So let's find the volume in meters cubed. That's going to be 2 times 2 times 2. Length times width times height. Or we could think of it as 2 cubed. It's just the same thing. The cubed means there's 3 2's that we're timesing together there. I'm going to break this down slowly. 2 times 2, that's 4. And then I'm going to really carefully make sure I times the 4 by 2, because lots of little accidental mistakes happen when we end up adding by accident instead of timesing, because our brains try to do things more quickly than we're ready for. It happens very often. So don't worry about slowing your brain down a little bit sometimes and just thinking, hey, okay, I'm just going to think about this. 4 times 2, that gives us 8. Nice one. I can see in the comments. Brilliant. And that is going to, I was going to also look at some imperial units with you. Probably these. Oh, that was what it was. You know what I've done? I've put the imperial unit slide in your practice questions instead. And that was something that I was going to show you. Why don't I just quickly tell you a little bit about imperial units, and then you can have a go at these questions as well, right? Because actually, now I've told you the basic idea of volume, whatever unit you come across, if you have a cuboid, whatever units the side lengths are in, as long as they're all in the same unit, you'll be able to multiply them together to find your answer, to find your volume. So for these 2 questions, in question A, we're multiplying together different side lengths that are all in inches. Okay, so our unit for our answer, I wonder if any of you can guess. Our answer is going to be in cubic inches or inches cubed, like this, right? Because all the side lengths are in inches, we'll end up finding out how many 1 inch by 1 inch by 1 inch cubes are inside the cuboid. This one is in feet. That's another imperial measure. So this answer is going to be in feet cubed. But you know what? It doesn't really matter so much knowing a lot about inches and feet unless you use them a lot. Sometimes people might use inches and feet a lot if they maybe are doing crafting, or sometimes if you're buying things online, you might have dimensions in inches and feet, but they should also be in centimeters. So it's just to show you there are other kind of measurements that you might see around, but you can treat them in exactly the same way. We can still find volumes in inches cubed or feet cubed or yards cubed or even miles cubed. That would be huge though, wouldn't it? Um, as well, as well as the metric units that we might be a little bit more used to seeing. All right. Hey, fantastic. Thank you so much. I see a lot of you came along today, and I know some of you might be watching on replay as well. Do feel free to rewatch on replay and think again about the things we've been talking about. Um, Also, if you download the PDF, you'll be able to see the answers to those questions, those practice questions at the end of the slides. So you'll be able to see how you get on with them. And I will really look forward to seeing you all next week. Lovely to see you all. Oh, you're so welcome. And I look forward to seeing you soon. Take care. Bye, everybody.